There's a lot of buzz about big data. Enormous investments are being made in using big data to analyze everything from weather patterns to stock market fluctuations to consumer buying behaviors. If this data, at all stages of its life cycle, is important to you, we believe you should protect it. The concepts of big data and data mining have been around for a long time. The reason it's getting so much attention now is because there are technologies available, Hadoop, MongoDB, Cassandra, MapReduce, etc., that really allow companies to harness their structured and unstructured data and use it to benefit their business. Not surprisingly, big data has been pretty successful in B2C companies like Facebook and Target, but it's taking off in B2B as well. We're talking to telephony companies that are using big data to track cell tower usage, and others are using it to monitor and learn from their machine data, viewing the performance of their SaaS applications and cloud environments to see whether they're meeting SLAs. We often hear from customers that there's nothing sensitive or personal being ingested or stored in their big data environment, that it's all innocuous machine data. Well, that may be true today, but what's also true is that big data projects tend to creep in scope. While you may be collecting and analyzing one thing today, it'll be something else tomorrow. Inevitably, sensitive information gets swept up. Maybe it's PHI, maybe it's credit card data, maybe it's customer transaction histories. It could be simply a list of employee email addresses. Whatever extra info you need to complete the analytics puzzle. This data should never be written to disk without encryption. Data in a NoSQL environment isn't centrally located, but instead it's massively distributed in the cloud, sometimes across thousands of nodes. Each of these distribution points represents an opening for unauthorized access or attack, so data is very vulnerable in this state. The threat of a malicious attack, either from an outside group or a rogue insider, is always there. In fact, a recent study on 2011 data breaches found that 14% of all breaches were due to a compromised database server. Not long ago, these attacks were carried out by well-funded organizations that were after money or power. Now a data breach can come from anywhere with really no warning at all, and with no reason other than, well, just because. For example, a Belgian bank was recently blackmailed for €150,000. The hackers said it was an idiot tax being imposed because the bank was foolish enough to leave confidential customer information, including full names, job descriptions, contact information, ID card numbers, and income figures, unencrypted on a web server. The damage done by a breach like this may reach into the millions of dollars, but it pales in comparison to what you lose in customer trust. Think about it. Would you keep your business at a bank that left your salary information unprotected out on a web server? For all the stories we read about data theft, the primary driver for data security remains compliance. As you know, there are a number of standards around data protection for HIPAA, PCI, FISMA, SOX, EU privacy, etc. This includes strong on-the-fly encryption, robust key management, and strict governance around access to those keys in the data. Our original mission at Gazang was to provide an encryption utility for the open source MySQL database. We launched our first ZEncrypt product in February of 2011, and later that year we expanded to include support for Postgres and the rest of the LAMP stack. Then we added big data support for Hadoop, Cassandra, MongoDB, etc., and that's where we are today. There are three things I want you to understand about Gazang ZEncrypt. First, we can secure your keys in the cloud or on premises. It's really up to you. Second, we provide process-based access controls to ensure only authorized parties have access. And finally, we can encrypt anything in your big data environment with absolutely no noticeable performance impact. And I want to stress the performance piece again. On-the-fly encryption will not impact big data performance. Access controls are hardly new or unique. We certainly didn't invent them. Most vendors that do encryption offer some form of access control list where a specific person or job function has the ability to request and gain access to certain files or data. But what happens when a person leaves the company, their role changes, or those files are no longer relevant to their job? How do you handle access when your data is stored in the cloud? And what about data stored in a SaaS environment? Who owns that data? There are a lot of complexities when you grant access to a person or a role. ZEncrypt instead uses process-based access controls. This means that only the process that requires the data can gain access. It's not tied to a person or a position. ZEncrypt sits between a file system and any database, application, or service running on Linux. It intercepts and encrypts data before it gets written to disk. And this is how you achieve true transparent data encryption without changing the database or application. One of the most common problems with any encryption solution is what to do with the encryption keys. Where are they stored, and how are they secured? Gazang Z-Encrypt comes with a patent-pending key storage system. This includes multiple layers of security to ensure your key is protected and available whenever you need it. Here's how the system works. First, each individual file generates a unique and random encryption key. The encryption keys are then protected by a passphrase and